Hello guys, welcome back to Manalasak. I hope you've all been well. So in this video I just want to do factorization because I understand that some people need help with factorization. So in this factorization video we're going to cover the topics that you see here. That is common factor, difference of two squares. The let k method is not a type of factorization. It's just a method that helps you factorize all the other types of factorizations that are there. And so we have quadratic trinomial, we have grouping of terms, we have the sum of two cubes and the difference of two cubes. So let's go ahead and just start. So here we are starting with common factor, right? Let me choose a pen here. There we go. So I want us to start with common factor, and there are a few things to consider there. I start with the simplest one. We have p raised to 2 minus 2p. And then we are saying take out a common factor here. When we are asking you for a common factor, we are asking you for what's common between the two things. So what I know is that in this space, I have 2 p's, and what I have here, I have 1p. So what is common between these two terms is the fact that they all have p's, right? So I take out a p as a common factor. When I take out a p here, it's like I'm saying p squared. I divide by the common factor. So what's left? What's left will just be 1p. I write that here. Minus. So here in 2p, when I take out a common factor, which is p, I'll be left with what? I'll be left with 2. So I write a 2 here. So when you take out a common factor, you take it out by dividing the remaining terms with the common factor. That's what you do, right? So let's do the next one. Let's say b, you have a question that says, let me divide this. For question b, let's say you have a question that says 9x raised to 3 plus 6x raised to 2. So now there are several things here. Our common factor comes in terms of a number, and it also comes in terms of a variable, right? Let's start with numbers. So if I have the number 9 and I have the number 3, what do they have in common? I can divide this by 3 and I can divide this by 3. So I want to take out 3 as the highest common factor there. So I take it out this way, right? And then afterwards I go to the variables now. With the variables, I have x cubed in one value and I have x squared in one value. What is common here? What is common is that here I have how many x's? 3 of them. Here I have how many x's? I have 2 of them. So they all have a minimum of 2 x's, right? They all have a minimum of 2 x's. So which means x squared is another common factor. So since now 3x squared is a common factor, I have to divide these things of mine by the common factor so that I can get what's remaining in the brackets. So I have 9x cubed divided by 3x squared. What happens? I say 9 divided by 3, that is 3. X raised to 3 divided by x raised to 2, I'm left with x. So what's left, I'm going to write it inside the brackets here, right? The next part, again. The next part, I have the 6x squared. I'm going to divide this by the common factor, which is 3x squared, right? When I say 6 divided by 3, I get 2. When I say x squared divided by x squared, they actually cancel out. 2 x's are divided by 2 x's. I have nothing left. So my answer is just 2, right? So I write 2 here. See how easy is that? So I'm going to do another one. But this time I'm not going to do this long method. I'm just going to do it and then we all flow, right? So question C. Question C says I have 25. I have a raised to 3. I have b raised to 5 minus 5 with an a squared and with a b. So what is common here? Between 25 and 5. I can divide this by 5 and I can divide this by 5. So 5 is the highest common factor here. So starting with numbers, 5 is the first common factor. How many a's do I have here? I have 3 a's. How many a's do I have here? I have 2. So they all have a minimum of 2 a's. So I'm taking out a squared as a common factor. How many b's here? 1. How many b's here? 5. So they all have a minimum of 1 b. right? Afterwards, I divide these things by the common factor to get the remainder that will be inside the brackets. So I have 25a raised to 3 b raised to 5. I divide that by the common factor, which is 5a squared b. So 5 goes into 25 how many times? 5 times. A squared go into a raised to 3, what's left? 1a. B goes into b raised to 5, what's left? B raised to 4. So this is what's remaining. 5a b raised to 4. Here's a subtraction sign, and then I do another one also. I'm going to say 5a squared b. I divide this by the common factor, which is 5a squared b. Right? So what I realized is that this is the same as this. They are just the same. So what is a number divided by itself? That is 1. That is not 0. The answer is 1. Right? So I'm left with 1 here. Easy as that. So here I have the following. And then here, this is what happens when you have to let k. Right? So I realized that, okay, here I have this and I have this. These things, they look complicated, but they look so complicated. So this bracket here, this whole bracket that is y plus 1, I want to represent it with something simple. So I'm going to say let this bracket, this whole bracket, be a variable like k, so that now I can write this in a simpler way, in the best way that I can, to make this thing make sense. So which means wherever way I see the bracket, I replace that with k, because I have a y plus 1 here and I have a y plus 1 here. So these brackets are the same. So here I have an x. Because there's a bracket next to it, that bracket I replace it with k. And then here's a plus. And then here I replace that also with what? I have a 2. I replace the bracket also with a k. This is where I am now. Now, this is something that makes a little bit more sense. I can work with this. So what do I do then? I take out a common factor. What is a common factor? A common factor is k and k in both situations. So I write k outside, and then what's remaining, I write in the brackets. If I remove k from this term, I'll be left with x. Here's a plus. If I remove k here, I'll be left with what? With a 2. However, this cannot be your final answer. Why? Because the question never came to you in terms of k. So where there is k, you substitute back what the value was in the first place. So what do I have? Instead of k, I write the whole bracket, which is y. Let me write that properly. I have y plus 1. That's the whole bracket. And then the other part that was attached to k, I also write it. This is k. I replaced it here. And then I have this term that was attached to k, which I'm supposed to write here. See how easy is that? I still took out a common factor here. In this term, I was able to see that, wait, this is a common factor. So what is the common factor? I knew that it was k. I took k out as a common factor, and then I got here. See how easy is that? Now, let's go to the next one. So here's the next one again, right? So what am I seeing here? I see that I have 2 brackets here, x plus 2 and an x plus 2. So again, I get to the situation whereby I have to solve things out. But I realize that the brackets are making things difficult for me. What do? I go to my method of letting k. I'm going to say let the whole bracket of x plus 2 be the same as k. So which means here I have k, but it's not just k, that is k raised to 4, because the bracket had an exponent of 4. And then what do I have? I have this plus 3. What else do I have? I have to replace the brackets again. Where I see the bracket, I'm going to say this is what? K. And the bracket was raised to what? 2. So now in this situation, I can take out a common factor here. What is the common factor? Okay, here I have 4 k's, here I have 2 k's. So I can just take out k raised to 2 and have that one out as a common factor. What will be left? From 4 k's here, I'll be left with 2 k's. Here's a plus sign in between. From the 3k squared, I'll be left with what? With just the 3. See how easy is that? That was nice. This is me letting k now, replacing complex brackets with an easier thing. Here's the next question. in this question now, things are slightly different. What I'm realizing is that I have a bracket of b minus a. This one is a minus b. This one is a minus b. So these two brackets are the same, but this one is different from all the brackets. So that will be tough for me to work with. But then I realized that this b minus a, it was so close to being like this bracket, right? So is it possible for me to move this bracket around such that it becomes like this? Yes. What I need to do is that I need to take out, let me see if I can find a pen here. I need to take out, can you see this? Yes. Negative as a common factor. So in front of this 3, I'm putting a negative here, right? So when I put out a negative in front of 3, whatever that had a sign inside the bracket, that sign is going to change. So here is an a. This a, because it was negative, now I make it positive. And this b, because it was positive, now I'm going to make it negative. That is the effect of taking out a negative as a common factor. We're good. So afterwards, I have a negative a here. I have an a minus b here. I have a positive 2b. And I have this bracket here. Now, where are we? Now we're in a beautiful situation whereby we see that this bracket, this one, and this one, they are the same thing. But working with brackets like that, again, it requires you to think too much, and we don't want that, right? So I'm going to say, put an arrow here. Let this whole bracket of a minus b be the same as k. Now, here's a question. Do you always need to make it k? No. You can make this letter to be anything. You can make it P, you can make it R, you can make it Q, you can make it anything. You don't always have to make it K, right? So, what do we have now? Here we're going to have negative 3, and then I replace that, the whole bracket with a K. See how easy is that? And then I have negative A. Next to A is a bracket, which means the bracket I'm also going to replace it with a K. Then we have positive 2b. Next to that bracket, next to the positive 2b, I have a bracket. I'm going to replace the bracket with a k. Now, what am I seeing? I'm seeing that I have 3 terms, a trinomial. And in those 3 terms, I have a common factor of k. Now, I'm taking out that k as a common factor so that I can be left with what was inside these things. So I have here, if I take out a 3, a negative. If I take out a k, I'm left with a negative 3. Here, what do I have? I'm left with a negative a. Here, what do I have? I'm left with a positive b, close bracket. Now, if you're someone who knows how maths works with me, I don't like things not being arranged in order like this. So I'm going to keep k outside as a common factor because I factorize that. Some people make a mistake of factorizing and then simplifying. Now, let me tell you this. When you are factorizing, don't find yourself simplifying. Don't find yourself opening brackets. Don't find yourself solving things out. Leave things in bracket. Leave things factorized. Don't simplify. Do not distribute. Do not FOIL. Right? Okay. So now here, I need to arrange this in order between A and B. Which one goes first? I have negative A going first, and then followed by the positive 2B. And lastly, I'll have negative 3. It's nice for expressions to be in order. We're good. So now we move on to difference of 2 squares. Difference of 2 squares, how do you notice this? Because when you get onto a question paper, you won't be told that factorize the following by difference of 2 squares or factorize the following by quadratic trinomial. You're supposed to look at a question and see that this thing here, it needs me to use this method of factorization, right? So now we are having 2 terms. That's one hint that this is difference of 2 squares, right? So number 1, that's the first hint. You must have 2 terms. Number 1. Number 2, those 2 terms need to be perfect squares, right? So x squared is a perfect square. 9 is a perfect square made of 3s, all right? Item number 3, you need to have a subtraction in between because of this is difference of 2 squares. So if it has a plus in between, this won't be factorizable. So 3 things. Number 1, you need to have 2 terms. Number 2, you need to have perfect squares. All of them must be perfect squares. Number 3, you must have a subtraction in between. That's how you notice difference of 2 squares, right? So now what happens here? Since this is difference of 2 squares, you want to break it down into its components that make it a perfect square. So this x squared is a perfect square because you took x and multiplied it by x, right? Here's a subtraction. And what makes 9 a perfect square? That is you multiplying 3 with 3. Good, right? So now after you get to this stage, then you factorize. You open two brackets. One bracket will be positive, the other bracket will be negative. Now, this first x, you put it here. This first x, you put it here. This first 3, you put it here. This second 3, you put it here. And it's factorized. You see how easy is that? You don't need to strain yourself. Difference of two squares is one of the easiest things to factorize. We good? Let's try another one. We have 9x raised to 3. No, sorry, that was the previous example. That was common factor. That was for common factor. Okay, let's say we have 4x squared. We have minus 9y squared. Right? So what is the first step? Again, go with me. How do we know this is difference of two squares? 4 is a perfect square. X squared is a perfect square. 9 is a perfect square. Y squared is a perfect square. We have only perfect squares here. That's the first thing. Number 2, we have two terms. So if it's two terms, it's most likely going to be difference of two squares. Number 3, we have a subtraction in between. That's how we know this is difference of two squares. Okay, let's break it down. 4 is the same as 2 multiplied by 2. X squared is the same as x multiplied by x. We have a subtraction in between. We have a 9, which is 3 multiplied by 3. We have a y squared, which is y multiplied by y. So in that situation, I'm ready to open two brackets to factorize. One bracket positive, one bracket negative. So this factor goes here and this factor goes here. This factor goes here. This factor goes here. These ones are after the sign now. 3 goes here. The second 3 goes here. The first y goes there. The second y goes there. Fully factorized. Then you're done. See how nice is that? So let's choose something else again. By this point, please make sure you pause the video and try this on your own to see if you understand. I have an x raised to 6 minus y raised to 4. We good? So now, what makes these perfect squares? Here, two things I multiplied to get a 6. I multiplied x raised to 3 and an x raised to 3 minus, here I multiplied y squared with a y squared. I know there is someone who didn't pause the video to try this on their own. It's okay. Here, opposite signs. I have a positive, I have a negative. 1x cubed will go there. 1x cubed will go there. Now we cross signs. After the sign, we have 1y squared and we have another y squared. Guys, this is not a problem. I don't see how this can be a problem. You see how beautiful is that? Let's get another one. We have 4 with an a raised to 2 minus 9 with a b raised to 2. Please pause the video and try to solve this on your own first before you proceed to see the solution. I know some of you don't. I know some of you are not pausing the video. Okay, fine. Here I have a 4. I have a 4, which is 2 multiplied by 2, fraction there. And then here I have an a squared, which is a multiplied by a. You keep it as a fraction because it was a fraction. Minus the 9 is 3 multiplied by 3. The b squared is b multiplied by b. I'm now ready to open two brackets. This first part here, you see it? These ones, they go here. 2 over a. Another one, 2 over a. See how nice is that? One bracket positive, another one negative. Does it always have to be this one that is positive? No, you can have negative positive or positive negative, right? Okay, the first 3 here, the second 3 here, the first b here, the second b here. Like we are doing the same thing over and over, guys. over and over. Now look at this one, A, B, C, D, E. We have 2y squared minus 2. Pause the video and see if you can solve. So what I would do, I would first notice that, wait, these things here, I have a 2 here, I have a 2 here. And this is not difference of 2 squares, even though I have 2 terms and a subtraction in between. But this is not difference of 2 squares because this is not a perfect square here. Right? So if I cannot factorize by difference of 2 squares, then I can take out a common factor. Common factor is always your first resort to dealing with any factorizing problems. Right? So when I take out 2 as a common factor here, on this part I'll be left with y squared, and on this part I'll be left with negative 1. Now look at this one. This one now does have difference of 2 squares. You see this part here, this part inside the brackets, I have y squared and 1. 1 is a perfect square and they're separated by a negative, and I have 2 terms. So this is factorizable by difference of 2 squares. I'm talking about something that's inside the brackets. So I have a 2 here, and then I expand this thing. This is y multiplied by y minus 1 multiplied by 1 this way. So I keep this 2 outside here. And then for the bracket, I start factorizing. Opening 2 brackets there. One bracket positive, the other one negative. This factor goes here. This factor goes here. This factor goes here. This factor goes here. Easy as that. Fully factorized. See how nice is that? Look at what we have here. Here we have x squared into brackets a plus b minus y squared into brackets a plus b. I'm sure you're pausing the video to solve it on your own first. Now, I'm not sure if you realize, but we are back at that situation of complex brackets. What do we do with the complex brackets? We replace them. I'm going to say, let this bracket of a plus b be the same as k, right? Then, moving on, this is going to be x squared attached to a bracket. I'll come to that. Minus y squared attached to a bracket. So let's go to that. The x squared here was attached to this bracket. This bracket I'll replace with k. This y squared was attached to a bracket. That bracket I'll replace with k. Right? Hope you can see that. And then what do I realize? I have y squared k. I have x squared k. I have y squared k. What did I say twice there? The k. K is a common factor here, right? I take out k as a common factor here. And then I'm left with what here? I'm left with x squared minus y squared. But is this thing fully factorized? Is there nothing else I can factorize here? You don't leave your factorization things halfway, right? I do realize that even though I did take out a common factor k and factorized, here inside the brackets, there is still something nice I can do in there. What do I see? I see that perfect square, separated by a minus, that is difference of 2 squares. So this is built up by what? By x multiplied by x. Here's a subtraction. I have a y multiplied by y, close bracket, right? And then what do we do from here? Then I have a k, and then I'm going to replace this with, here I'm going to say open 2 brackets because this is difference of 2 squares. One bracket is positive, the other one is negative. This x goes here, and this x goes there. This y goes there, and this y goes there, right? And then is it fully factorized? Yes. Except now for one issue here. The issue is that this thing, even though it's fully factorized, something is not right. The question didn't come to me in the form of k. So why am I leaving the answer in the form of k? Right? That is not right. So where I see k, I need to return now what I borrowed. This k was what? It was a bracket of a plus b. And then I now attach everything else, which is x plus y and x minus y. Voila. There we go. Well, here we go again. What do we have? We have a complex bracket. I'm sure you know what to do by now. complex bracket, replace that with something that is more easier to pronounce, like k, right? So which means here I'm going to have what? I'm going to have k squared. And then, because why? The bracket was already raised to 2, so the k has to be squared. And then minus 4. Then what do I see here? K squared is a perfect square. 4 is a perfect square. Open 2 brackets for that. I'm going to have, before opening 2 brackets, k multiplied by k, right? And then I'm also going to have minus 2 multiplied by 2, because that's what makes 4. Then moving forward here, this is going to give me what? This is going to give me a situation where I have to open 2 brackets. One bracket is positive, the other one is negative. And I have this k now falling this side and this k falling this side. And then I have this 2 here, this 2 falling this side, and this 2 falling this side. Fully factorized, but however I did not answer the question because the question didn't come with a k. So if the question didn't come with a k, what do? We are going to say, so here I'm going to have in this situation, you see this bracket that is open here, I have to keep it open, right? And this is tricky because I have to make sure everything is perfect. Where there is k, I replace with the bracket, and this part comes with its own bracket. So I have a bracket, x plus y, close bracket, like that, right? And then I have a plus 2, and then this bracket is closed here, close the bracket. I open another bracket, and then we have a k there. Where there's a k, we open bracket, then we have x plus y, and then we do it this way, and then that's how it's supposed to be. So we replace the brackets and then properly so, and this is how it's supposed to be. So now we are working with quadratic trinomials, and then quadratic trinomials are not really that bad. How do you notice them? Number 1, you must have 3 terms. That's how you see them. You must have 3 terms. Then you know this is a quadratic trinomial. And what else? The coefficient of x squared, it's usually most likely supposed to be a positive 1, right? So this, it's supposed to have a coefficient of positive 1, especially for your grade. And then you must have something, an x raised to 2 and an x that is raised to 1, right? So 3 terms, x squared has a coefficient of positive 1. That's how it is. Oh, this is a tongue twister. Okay, let's see what we can do. So here what you're supposed to do here is that I want you to open 2 brackets for me right from the start. And then afterwards, the first factor will be based on the first term. So when the first term is x squared, you're going to have x here and x here, right? And then if this 6 is positive, it means you are going to have the same signs. Now, this 6 being positive, it doesn't tell you which same signs are you going to have. What tells you which same signs are you going to have? It's the sign in between here. So this is which signs. So this tells you that you will have, if it's a positive, it tells you will have the same signs. And what will those signs be? If this is positive, then you'll have a positive and a positive. And if this last term it's negative, that will mean different signs. So since we know that all your brackets are positive, we want factors of 6 that can give you 5. So factors of 6, you have 6 and 1, you have 3 and 2. The only ones that can be all positive and give you a 5 are these ones, 3 and 2. So you put a 3 here, you put a 2 there. Right. Easy. Now, next one. You have x squared minus 9x plus 8. This is a quadratic trinomial factorization. How do you know it? You have three terms, and the coefficient of x squared is positive 1. Right? So, what does this positive on 8 tell you? It tells you that you will have same signs. Now, what will those signs be? They will be negative, right? So, open two brackets. We know that your signs in the bracket will be the same and they will be negative. So, this x squared has a factor here and this factor here, right? Factors of 8 that can give you a 9, that is 8 and 1. If you add 8 and 9 and 1, you get a 9. So I have 8, I have 1, and this is fully factorized. See how easy is that? Quadratic trinomial. It's one of the easiest things to factorize here. Right. So let's say again we have x squared minus x minus 12. What does this negative on the 12 tell you? It tells you that you will have different signs, right? So we open two brackets and we know that our brackets have different signs, positive and negative, or negative and positive, whichever way. So factors of x squared, that is x and x. Factors of 12 that can give us 1, we have 1 and 12, we have 2 and 6, we have 3 and 4. The only ones that are 1 unit away from each other is 3 and 4. Now, in that 3 and 4, in this 3 and 4, one of them needs to be positive, one of them needs to be negative. How do we know that? Well, if the middle term is negative, then the bigger number must be negative, right? So 4 will be negative and 3 will be positive. Easy as that. Another question? Let me choose the next slide for this one. Here we have 12m squared, 16m raised to 3 minus 2m raised to 4. And I'm telling you, this is a quadratic trinomial. Now, how would you factorize something like that? Now, what you need to understand is that in most situations, you don't get to use one type of factorization. It's there in grade 10. That is the grade 9 thing. That in grade 10, you will get a question that will want you to factorize something once. Yeah, it's there. I won't say it's not there. It's there. But we really prefer someone to factorize something twice. So when you look at this thing, this is definitely not a quadrinomial. The way it looks, no, it's terrible. Right? So there must be one form of factorization that works here. And that would be what? Common factor. So we start with what's common. Let's start in the numbers segment. We have a 2, 16, and 12. What is common? That is a 2. I take out a 2 as a common factor on the number side. Then I go to the m's. How many m's that are common in each and every term here? Well, here I have 2 m's, here I have 3 m's, here I have 4 m's. So they all have a minimum of 2 m's. Right? So now I'm left with what? In this situation, 12 divided by 2 will be 6. And then I remove 2 m's, so I no longer have an m in this situation. Subtraction, minus 16 divided by the common factor, that is 8. M raised to 3, if I take out 2 m's there, I'm left with 1 m. Here's a negative. 2 divided by 2, that is 1. I can put a 1 here, or I may not put it, it's fine. And then I have what here? Out of 4 m's, if I take out 2, I'll be left with 2 m's. Right? So you might think this is no longer factorizable, but it is factorizable. Things just need to be put in order for us to see them. Remember what I used to say? Always leave your values in the proper order. Right? So let's put this in order. The one with the highest exponent goes first. This is negative 1m squared. Here it is, negative m squared. I don't need to write the 1. Right? And then I have what? A negative 8m. And then what? I have a positive 6. Right. So this is a trinomial. It's a nice trinomial. Except that the coefficient of m squared is negative 1. And it's supposed to be what? Positive 1. So what I'm going to try to do is to take out negative as a common factor and see if that works for me. If I take out negative as a common factor, it will go in front of the 2. And what will I be left with? inside the brackets, everything changes a sign. What was negative now becomes positive. What is negative becomes positive. And what is positive becomes negative. Right. So, and then now in this situation, this is okay. And then now in this situation, I have this thing here. At this point, I have this trinomial inside the brackets here, in which is not really factorizable. It's not really factorizable because, let me show you here. When you open two brackets here, you will have m and m. Here, the 6 is negative, which means you must have opposite signs. And then factors of 6, there are no factors of 6 that can ever give you an 8 if they have opposite signs. All right. Right. So what happened here? What happened is that I made a mistake on this part here, but I'm not going to erase it. I'm also not going to edit it out of the video. Let me do this. Just going to fix it here. I won't cut this part out. I'm just going to write the right one here. This thing for me was supposed to be negative 16 m squared plus 12 m raised to 3 minus 2 with an m raised to 4. This is what it was supposed to be. So I just checked it now, the exercise, and it was supposed to be like this. So what happens here? What happens is that I'm supposed to take out a common factor. Let's start again. My common factor here will be 2. Take out 2 as a common factor. And then m squared is also a common factor. I take out m squared as a common factor. What am I left with? I'm left with, open brackets. Here, if I divide the negative 16 by 2, I'll get negative 8. And then m squared divided by m squared, I no longer have m's there. Plus 12 divided by 2, that is 6. M raised to 3, I'll only be left with 1m if I remove 2 m's there. Here's a negative, I put it there. 2 divided by 2, that is 1. M raised to 4 divided by m raised to 2, that is m raised to 2, this way. I'll arrange this thing now, which means here I'll have 2m squared, and then inside the brackets I'm going to have, in order, negative m squared plus 6m minus 8, this way. Right. So afterwards, I realized that m squared is negative and it's supposed to have a positive coefficient. So what am I going to do? I'm going to take out negative as a common factor. The negative goes outside, all the way in front of the 2. And then afterwards, everything inside the brackets changes sign. Right? So I have m squared here. What was positive now becomes negative. What was negative now becomes positive. And then this common factor, I keep on dragging it. I don't leave it behind because I need this. Right? So, and then afterwards, this is a perfect quadrinomial now. I open two brackets. If the 8 is positive, it means I'm going to have the same signs. Which same signs are those that I'm going to have? They are based on this answer here. If this is negative, my same signs will all be negative. This m squared will have a factor here and it will have a factor here. Factors of 8 that can give us 6. 8 and 1 can never give us 6. But 4 and 2, if they're both negative, they can give me negative 6. So that's my fully factorized version of the thing. Right? So on to the next question. So here's the next one. I tried to write this one in small font so that it can all fit here. Right? So this might look like a scary question for factorization. But if you're listening to what I was saying throughout these past examples, you will realize that this is not as bad as it seems. Right? So brackets, complicated brackets. What do I need to do? I need to replace those brackets with something more simpler. X squared minus 3x, x squared minus 3x. So I'll replace that with k, right? So which means this is going to be what? K squared. Then here I have a 2 minus 8, and the 2 is attached to a bracket, which makes this 2k, right? Yo, my tongue, it's like today I just can't say things. Okay, so what do I see here? I see a simple factorization problem of a quadratic trinomial. So I open two brackets for that. If the 8 is negative, it means I'm going to have opposite signs. I have a k squared here, which means I'll have a k and a k. Factors of 8 that can give me a 2. Well, I have 8 and 1 as factors of 8. I have 4 and 2. So if these things need to have opposite signs, 8 and 1, no matter which one is negative, they'll never give me a negative 2 as an answer. But 4 and 2 can. So which one should have a negative? Well, if my term here is negative, then the bigger number must be negative, right? Which means the 2 will be here. It looks fully factorized, but this cannot be my final answer. Why? This cannot be my final answer because it was never given to me this way. I never had k's in the question. So if I never had k's in the question, I need to replace things to how they are supposed to be. So I'm going to say here, wherever where I see k, I replace that with the right thing. So firstly, this bracket, I'm going to open it here, right? And then I have my k, I'll replace that with a bracket, x squared minus 3x. Return the things now. Here's a plus, here's a 2, here's a bracket, open another one, then a k. A k, what we do, we replace that with the bracket that we replaced k with, close the bracket of k, return things, minus the 4, close bracket. And then again, this is still not fully factorized. Inside the brackets of k, where you see orange there, I see that, wait, I can still factorize this. Inside this bracket here, there is still some little bit of factorization that can happen in there. So I enter the brackets and I factorize those things. So what am I going to have? I open this bracket. This one, I open this bracket. And then I deal with the k. In this k, I'm going to take out x as a common factor. But I don't send it all the way in front. I just send it outside the bracket of the orange bracket. Let me call it like that. I just send the common factor right outside the orange bracket, which means my common factor, since it's x, it stays like that. And then what's left in here? What's left is x minus 3. Close that. And then I'm going to have plus 2. And then here also I take out a common factor here that it goes right in front of the orange bracket. So I have x, and then I'm going to have, I'll be left with x here minus 3 here, close bracket. This is just a lot, and it's easy for a person to make mistakes here. Minus the 4, close the bracket outside there. Now it looks fully factorized. See that? I don't feel like inside the bracket here there is anything now factorizable. These things are in different brackets. I cannot take out the orange part as a common factor because this orange part, it is in this bracket, and the other orange part, it is in this bracket. So can't take those things out now. We're good. So now let's move on to the final stage of factorization. The final stage. Okay, I was lying, guys. This is not the final stage. This is the second last stage. So we have grouping of terms. Grouping of terms, which is straightforward. It is like common factor. In fact, it's not like it has common factor. Let me write this question first. EY. So now in this situation, what you need to do is you need to group things together and then solve them out. Like for instance, I'm going to take these two terms, group them together. I'm going to take these two terms and group them together. What do I have? I have ax plus bx grouped together in a bracket. Here I have ay plus by grouped together in a bracket. But this stage, I want these things to be a binomial. right? So these things that are grouped together now, I want to take out common factors. So in this situation, I have ax, I have bx. So obviously the common factor is x, right? And then what will be left inside the brackets? I'll be left with an a plus b. Now this type of factorization, it's full of trial and errors. You might factorize something, get stuck in the middle of the way. You have to go back and restart your factorization now in a different way. So don't feel bad if you ever go through that. It's possible. All of us go through that. Here I have ay and I have by. So I take out a common factor here, which is going to be a. No, there's no a here. I have ay, by. So y is a common factor. I'll be left with what? I'll be left with a. And here I'll be left with what? I'll be left with b. So now, what I want to say now is that this thing, a plus b and a plus b is the same. I'm going to represent those things now with one bracket, right? And then afterwards, I have an x, I have a y here. Those orange parts, I'm going to group them together in one bracket. And this way, they are fully factorized. Not too bad, is it? I don't think it's too bad. B, suppose we have x raised to 3. Don't worry, this thing just keeps on getting harder the more we proceed with it. It just keeps on being difficult and difficult and difficult and more difficult as we continue. So I have this situation now. Need to take out common factors. And then we do the same thing. We group things. So I take these things, group them together. This way I'm going to have x raised to 3 minus 3 x squared. And then here, open brackets, I have negative 4x plus 12. This way. Right. So what do I have here? This thing is supposed to be a binomial. So I'll put a plus in between. I take out a common factor here. My common factor here will be the same as x. What's left inside the brackets? That is going to be, select that. Wait, x is not a common factor. X raised to 2 is a common factor. Yes. So I'll be left with x here minus 3. Right? Afterwards, I take out a common factor here. My common factor, I take out 4. Because I have negative 4x, I have positive 12 here. So if I take out 4 as a common factor here, I'll be left with negative x plus 12. Oops, sorry. My bad. If I take out a common factor here, I take out 4 here, I'm left with negative x. I take out 4 here, I'm left with 3. This way. Now the difference here is that these brackets could have been the same. Just that what I did, this one is positive, this one is negative in terms of x's. And here 3 is negative, here 3 is positive. So there's been a swapping of signs. So I need to fix that issue of signs. So I have an x here. And then, oh, this x is squared again. Keep on forgetting. I have here what we call, what is this? X minus 3. And then here I take out a negative as a common factor, giving me what now? If I take out negative as a common factor, this 4 will now be negative, right? And then if that 4 is negative, I'll be left with inside the brackets, what was negative will now become positive and what was positive will now become negative, this way. And afterwards, this bracket and this bracket are the same. I'm going to represent them with one bracket, x minus 3. And then all the orange parts, I'm going to represent them with one bracket, which is going to be equals to x squared minus 4. Now, you might think we are done here. You might think we are done. But those who see it, they can see that the orange part is still factorizable. So, we are not really done. Not by a long shot. So let me put an arrow here because I cannot have two equal signs. I put an equal sign here. So now the white part is okay. I just need to fix the orange part. So white is x minus 3, which is good. Now I need to fix the orange part. And I'm going to skip some steps to do that. I see that this is x squared. This is 4. X squared is a perfect square and 4 is a perfect square. and I have a minus in between. This is what? This is difference of two squares. So I open two brackets for difference of two squares, which I think by now, you already know how to factorize the issue of difference of two squares. So this is x multiplied by x minus 2 multiplied by 2. This is this part here. This orange part, this is how it is. I expanded it here, which means the first x goes there, the second x goes there. The signs will be positive and negative. The first 2 goes there, the second 2 goes there. There we go. Now it's fully factorized. See how nice is that? Next part. Here's another one. Try to pause and see if you can solve it on your own before you proceed to see the solutions. Okay, so here's what I want to do. Trial and error again. Let me see if this will work. I'm going to group these two together. So that is a raised to 3 b squared plus this. I put a plus in between. I have a negative a raised to 3 and a negative 1 this way. Right. So I take out b squared as a common factor. Here is b squared. Here I'm left with what? A raised to 3, and here I'm left with positive 1. Right. And here I have plus. I take out what as a common factor? There's really not much to take out. There's nothing similar between the two. So I have negative a cubed and negative 1. So the brackets are not the same. What is the issue now? The issue is that this one is all positive, this one is all negative. Okay, let me fix that. I take out negative as a common factor to see if that works. Here's a negative, it's no longer a plus. What was negative now becomes positive, and what was negative also becomes positive, right? So now if I took out negative 1 here as a common factor, and this thing is like this way, I can easily say now these brackets are the same, this one and this one, which is going to be a raised to 3 plus 1, and then these parts here outside, I'm going to represent them also with one bracket, right? And then what do you see? I see that this thing is further factorizable. This part is also further factorizable, but you don't know that yet. I'll focus only on this part here, right? The b squared minus 1, this is difference of two squares. By now you should know that. So I have a positive and a negative. B squared is made up of b and b. 1 is made up of 1 times 1. There we go. Right. On to the next part. What do we have here? I'll try to group things again and see if that works for me. Okay. Let me group these two here. Boom. This is trial and error. Remember that. I have x squared minus 9. What do I have here? I have a positive 3xy minus x squared y. Right. So when I look at the first bracket, here it is. I can see I have difference of two squares in the first bracket. And I'm going to now, moving forward, represent the first bracket with an orange color. So I open two brackets for the first bracket, whereby one bracket is positive, the other one is negative. Factors of x squared, I have x and x. Factors of 9, I have 3 and 3. I'm sure you know difference of two squares by now, right? And then here, I want to take out a common factor. Let me take out x, y as a common factor because I also have xy here. So I take out x, y as a common factor. And then inside the brackets, I'm left with a 3 here. And then here I'm left with a minus x. Do you see that? I take out xy here. I'm left with a minus x. So the part in orange, let me continue writing it in orange. I have x plus 3. I have x minus 3. And then I have this issue here. That this bracket could have been like this bracket. Except that in the one situation, one part is positive, the other one is negative. So changes need to be made there, right? So let me use a yellow color here. I'm going to take out negative as a common factor so I can swap signs around. So now this is negative xy, right? Still a binomial, And then inside the brackets, I'll be left with what? The x that was negative, it will now become positive. The 3 that was positive, it will now become negative this way. So Whew. Then what? Then what I realize is that this part here and this part here are the same. And we are like incorporating too many things now. And like I see too many brackets, all those things. And I'm like, oh, wait, this is too much for me. I have x minus 3, I have x minus 3. These are the same brackets. Why don't I just go and replace those things with, you know what I want to do? Let these brackets that are the same, x minus 3, bk. So which means now here, this part here that was x plus 3, it stays, but it's now attached to k, right? And then here in this situation, I have the negative xy. The negative xy, it's now also attached to, this is k in red. It's now also attached to k. And what do I realize between those two things there? I realize, wait, those two things are common. So that's a common factor, right? So I have a k as a common factor, which means now inside the brackets, I'll make those brackets white. Inside the brackets, I'll be left with this bracket here of x plus 3. And then I took the k out, so that is no longer there. And then here, I'm left with a negative xy. Then I close the white brackets because they also need to be closed. Nice. See how nice is that? Then afterwards, I was never given the question with k's. So I need to throw the k away, replace that with what was there initially, right? So there by k, I'm going to throw in the right term here, which is going to be equals to, what is that, x minus 3. And those things were in brackets. And then I have the white brackets. Then the orange brackets. Then the yellow part. Then the white part. Nicely factorized. Nicely factorized. You see that? Now let me throw in the last part here for grouping of terms, because I feel like we've been doing grouping of terms for too long now. So I have P plus Q plus PQ plus 1, right? So I want to group these things like this, but I see that, wait, these things have nothing in common and these ones have nothing in common. So I need to move things around, right? So this P, I'm going to bring closer to it PQ. So which means this PQ, and I'll move it here, right before the Q. And then here I'll have Q, here I'll have 1. So not everything can be factorized here, but at least one of them is factorized. Unlike here, where I was unable to factorize anything, right? So now this part here, I'm going to represent it in orange, right? So I put these ones in brackets together, grouping them, and then I have plus, and I have Q plus 1 here. See that? So now what happens? What happens is that this part that is in orange has common factors. I take those common factors out. So P is a common factor. I take it out. Oops. Choose something nicer. Something more visible. The orange is fine, man. P, I take that out as a common factor. Here, if I take P out as a common factor, I'm left with 1. And then here, I'm left with Q. Plus, here, what can I take out? Nothing. So I'll just take out 1 as a common factor. At least I did something, right? And then this bracket is the same as this one. Even though things are just moved around, but Q is positive here, it's positive here. 1 is positive here, and it's positive here. So these brackets are the same, right? So now the P and the 1, positive 1, I'll represent them with one bracket. P plus 1 in one bracket. And then another bracket will have what? Sure, you would have guessed. That is 1 plus Q. Or even if you say Q plus 1, that is okay with me. Perfect. That was easy, right? So now for real, let's move on to the last part of factorization. And that last part is going to be the sum and difference of two cubes, right? So I don't think this one is that much hectic. Just people are scared of this thing because if it's a new topic of factorization that is being introduced in grade 10, unlike in grade 9 where you have the first 4 that I mentioned above. Trust me, this is not the most difficult one in all the types of factorization. So now, which means instead of having 4 types of factorization, you have 6 types of factorization, right? So let's move on with that. This video has already crossed an hour now, right? So I have choose a thing. I have something that is written as x raised to 3 plus 1. Now someone would ask, is this the sum of 2 cubes or is this the difference of 2 cubes? Well, I mean, the trick is in the sign. The name giving is in the sign. If we have a plus, that's a sum of 2 cubes. If it's a minus, that's the difference of 2 cubes. And there's no difference between the two. Or it's there, it's just minor, right? So now, let's do this. I have an x cubed. An x cubed is formed by x multiplied by x squared, right? Keep it like that. And then here I have a 1. A 1 is also a perfect cube that is formed by 1 multiplied by 1 squared, right? So after seeing that, I open 2 brackets. One bracket must accommodate the binomial. The other bracket must accommodate the trinomial. So the sign of the small bracket, it must be the sign of the problem, of the question. So the question had a plus, the small bracket is going to have a plus. So now, what do we have? If this thing is a plus, the first sign is going to be a negative, and the last sign in the trinomial bracket, it is always positive. That looks like a 7. The last sign of the trinomial, it's always positive, right? Now I move to the factors. This factor here goes in this bracket, and this factor here goes in this bracket. The one factors that are raised to 1, that have an exponent of 1, they go into the small bracket. Now the ones that go to the big bracket now, it's the x squared, which takes the first position. It's the 1 squared, which takes the second position. Now we need a term in between here. What is that term? That term in between, it's you multiplying these values here. X times 1, that is x, right? And then you simplify that. Not really simplify, I just don't need squares in numbers, right? Here where there is 1 squared, that is the same as 1. And then it's fully factorized here. Easy as that. See that? That is really not difficult. Another one. B. This one I'm going to do it faster. Let's say you have y raised to 3 minus 8. What do? You're going to say y multiplied by y squared minus 2 multiplied by 2 squared. That is how you get 8, right? So, how did we know this is 2 multiplied by 2 squared? Because of 8 is the same as 2 raised to 3. And 2 raised to 3 is the same as 2 multiplied by 2 squared, right? From there, I open 2 brackets, one for a binomial, one for a trinomial. Let's go to the signs. If the problem has a question that is a minus, I'm going to put a minus here. Now, this is difference of 2 cubes, right? And then the sign in between here will be the opposite of this, which is positive. And the sign, the last sign, it is always positive, right? Now, the ones that have an exponent of 1, they go to the first bracket. I have y, I have 2. And now the squared goes here. And there's another squared goes there. And how do you get the term in between? You multiply these things together. Y and 2 together, that is 2y. And afterwards, you simplify this part here. You have y minus 2. You have y squared plus 2y plus what is 2 squared? 4. Easy as that. I feel like this is easy. Let's try another one now. Question C. Let's say we have 27 a raised to 3. Maybe with plus b raised to 3. Fine. Let's see what we can do here. Here we have to rewrite these things in exponential form. 27, that is 3 raised to 3 a raised to 3 plus b raised to 3. And then we break them down. This is the same as 3 multiplied by 3 squared. This is the same as a multiplied by a squared, a positive. This is the same as b multiplied by b squared. Then we open two brackets. This sign of the question is the sign of the smaller brackets, and then the sign in between is the opposite of the sign, and the last sign it's always positive, right? The ones with exponents raised to 1, they go into the first bracket. So these ones, they come before the sign, the positive sign. So also here they'll come before the sign. That is 3a. The b comes after the sign. Also here it will come after the sign, this way. And then the 3 squared and the a squared will be here, right? And then the b squared will be where? Here. We need a term in between now. We multiply these two together. You're going to have 3ab. And then we sort of simplify these things further. I have 3a plus b. What is 3 squared? That is 9a squared minus 3ab plus b squared. See how nice is that? So here we have the following. It's still difference of two cubes, just that this one wants to be sneaky here. So we're going to say this is the same as x raised to 3 multiplied by x raised to 6, because this one still needs to be an even number exponent, right? And then minus, here I have y raised to 3. This is the same as y multiplied by y squared. Open two brackets. Once you do a lot of these things, guys, you'll no longer suffer. This is negative. And then the ones here with lower exponents, they go to the first bracket. I have x raised to 3. I have a y there. How are the signs? The middle term will have the opposite sign of this one. And the last term will always have a positive sign. So the last term will have a y squared here. The first term will have an x raised to 6. And how do we get a value of the middle term? You multiply this 2. Such that x cubed multiplied by y, that is the same as x cubed y. See that? Fully factorized. No more issues there. Now the last one, I'm also already tired now. The last one, what can I take? Let me take this one. Negative 2 x raised to 4 y plus 54 x y raised to 4. Oh, I'm so tired. What do I need to do? Well, this is either sum of two cubes or difference of two cubes, but there is something missing here. A 2 is not a perfect cube. One thing for sure. So let me take out a common factor. I take out 2 as a common factor. What am I left with here? Wait, that is not the only common factor. That is not the only common factor. But we need to be strategic about this one. I take out 2x and a y, right? I'm saying 2 out because 2 can go there and can go there. I come to this one. I have x raised to 4. I have x. So x is the highest common factor here. Here I have y and a y raised to 4. So y is the highest common factor in y. Right. What am I left with here? I'm left with a negative. The 2 is out. The y is out. I'm only left with an x raised to 3. Then plus 54 divided by 2. That is 27. And then the x is out. I'm left with a y raised to 3. I want to move things around so it looks better. So I'm going to put the 27 y raised to 3 first minus the x cubed this way. Now it does look like the difference of two cubes. What do I have to do? I just need to show it. 27 is the same as 3 raised to 3. And then I have a y raised to 3. I have an x raised to 3. And then I break it down. I have a 3 multiplied by 3 squared. I have a y multiplied by y squared. minus an x multiplied by an x squared. Almost done. Almost. I have 2xy. I open two brackets, one for a binomial and one for a trinomial. So if the question for me now starts here because I moved things around. Right? If here I have a negative, it means here I'll also have a negative. The ones with single factors, they go first here. And this one also with a single exponent, I mean not vector, it goes first here. And then this one with an y raised to 2 and then 3 raised to 2, they go here. 3 raised to 2, y raised to 2. The sign here is the opposite of this one, which is positive. The middle term is 3y times x, which is 3xy. The last term is this part here that is raised to 2, which is positive x squared, because this part is always positive. And then I need to write this in the simplified form. I'm sure you can do that. Let me see. I have a 2xy. This is 2xy in case you don't see it properly. That is this part here. I have a 3y minus x. And then I have 3 squared, which is the same as 9. I have a y squared. I have a plus 3xy. And I have a plus x squared. Done. Fully factorized. So, guys, I'm happy if you were able to reach this part of the video. I hope you no longer struggle with factorization, because we have to move on to parts that are very dependent on factorization. Factorization is a grade 9 topic, so I actually did it for you guys, the grade 10s, because I see that most grade 10s in term 1, they struggle with factorization, and they do need factorization to pass term 1. In maths, guys, if you can't factorize, the best thing to do is to learn how to factorize. That's solution number 1. Solution number 2, you quit maths, because you can't continue with maths if you cannot factorize. So if you do not know how to factorize, my first solution is learn how to factorize. My second solution, if solution number 1 fails, is that you just have to drop maths. I love you guys. I hope you study and be ready for the upcoming tests. Goodbye for now, and we will see you on the next video.